Hi, this is Bernard Brolt with OTN System. This is part 3 of a video series on XTRan interoperability with TDM legacy network, basically mapping C37 and mirrored bits using a Schweitzer C37 converter over a T1, different channels on a T1, and ending it off to a foreign channel bank like you see on this application. I've done two previous videos that I'm inviting you to look at. The first one describes these applications, this one here and this one, for example, where interoperability with the Jungle Mux Sonnet system. The second video goes more into detail, back-to-back testing on the C37 converter. And finally, in this very last video, I have this setup in the lab. So this is the setup I have right now, and I got the XTRan connected to these two networks, and there's a T1 in between. Mirrored bit tester testing latency and so on of the C37 going across the T1 back to the other network and back into the C37, and in parallel with this having a transfer trip. You might actually hear in the background some clicking, and that's a transfer trip generator, and you hear the Schweitzer DTT relays sort of latching in and out. So I have I believe in the next one, here's a picture of the setup. So what you see here down there on the left is 3 nodes. It's a 2215 shelf and 2210 and 2 smaller. This is a smaller 1104 and another 1104, and same thing on the other side. The blue cables here are the MPLS links, so this is in a ring. This blue cable here is my entry point to the left network. On the right hand side you see a similar setup, except now you have green RJ45 doing the MPLS ring. What you see on top here is the Schweitzer DTT test panel. What you see on the left there is a counter calculating how many transfer trips are being sent to this module. The transfer trips are going to this card here, C37, gets mapped into the T1. T1 goes across this red T1 cable into the far end T1, back into the shelf and into this DTT. And as you see the counters there, at the time I took the picture, 79 trips have been sent, 79 trips have been received at the far end. And I'm going to also show you the results in terms of latency in both directions, asymmetrical delay, and so on. So that's the lab setup that you have right there. So now let's move to just for a second to XTRan right here. So and XTRan, well, that's the basic setup that we saw earlier, showing the C37. Let me go to the network tab and showing the 4 different circuits. So here's the C37 going down to that T1 port connecting to the other side, and the other end of the service is right there. So that's what XTRan is showing. So now let's go into looking at the serial tester, the mirrored bit tester, to look at latency, and it's right here. So we see here that this is running. It's so far transmitted something like 377,000 frame, received all of them, 0 errors, 0 CRC, no out of frame sequence, and a latency in one direction, end to end. This is going from C37 to the T1, out from the T1 to the next T1, and back into the C37 is 4.7 millisecond, which is excellent. And latency for the return trip is 4.2, and the difference, asymmetrical delay, as you can see, never exceeded 137 microseconds. So this is like a very solid link, that what you see there. What I want to show you is, of course, if I were to unplug the T1 cable, there's this T1 cable in between, and I'm just going to pull it out and show you that everything's going to stop. And I just pulled out, of course, everything's been lost, and now you're running like 100% errors. But if you go back to XTRan and look at the network, what you'll see is if you look at the alarm tab, you're going to get all these minor alarms that are gradually coming up. So loss of frame, loss of error. So it's complaining about circuit emulation on the T1, complaining about the C37, and so on. So if you look at this network right there, all of these C37 are currently all in alarm. So that's quite normal, because basically we've lost everything through, because it's all running through that single T1 cable. So that's maybe the downside of it, but that's the nature of mapping to a T1. Going back to this slide, so let me show you what I did. Just pulled out this one T1 cable, and of course we're losing that T1 and losing the tester there, and losing the transfer trip. So going back to the tester, we're going to reconnect the T1 cable, make sure everything comes back clean, and you should hear the transfer trip starts getting across. There you go. And as you can see here now, the DTT timers show that of course we're missing a whole bunch of trips that didn't get across, and the errors are clearing up again. So I'm just going to reset this counter right now, and everything should be back up to 0. And now you see that the asymmetrical delay is 150 microseconds, which is below the 200. And you can see here some adjustment on the de-jitter buffers, and you see up here latency in one direction being 4.5, latency in the other direction 4.3. These are all very good, and errors are all clearing up. And if I reset the counters, I won't see any more errors. I'm probably going to run this 24 hours. If I see anything exceptional, I'll come back to you. But that pretty much is the end of the video series. I hope you enjoyed this, and feel free to contact us at any time. All right, thank you very much.